Yes, so I'm Arthur, and like Andy said, I'm the co-chair, but Andy asked me to give a quick talk on SRFI, the Scheme Requests for Implementation. So I'm doing that here today. Um, yeah, so I'll give a quick overview of what SRFI is, a quick history, and then I want to give a flavor of the progress that's been made in the SRFI world since ICFP in 2018. I'm setting that marker in time because I gave a talk in the Berlin 2018 ICFP on the sort of status of SRFI. At that point, SRFI had just reached its 20-year mark. So it started in 1998 and had been going all that time. And then I'll tell you a story. So what is SRFI? To put it in context, for Scheme, there are kind of two ways that the language gets standardized. There are the Scheme reports, and then there's SRFI. And the Scheme reports are, all the RNRSs, and then there was also an official IEEE version of Scheme, which came out around the same time as R5RS, and was almost identical to that. Those all, the reports and the IEEE version all are based on consensus, and they describe the entire language and its libraries, not just some slice of it. And they are slower. It takes a lot longer because they're based on consensus to achieve consensus. And so, for example, R7RS small. So R7RS has been divided into two phases. R7RS small finished in 2013, and we're still working on R7RS large, and it looks like it's going to be a number of years before that is finished too. There's actually going to be a talk by John Cowan, who's the chair of that committee, later today. So SRFI, on the other hand, specifies just one piece of the language, just one feature, one library, one extension to the language, not the entire language. So that makes it a lot easier to make progress, and it's also a lot faster. The other thing is SRFI is not about consensus. It's about one person coming up with a design. It might be his or her own design, or it might be a design, for example, taken from the Racket world and trying to incorporate it into the rest of the Scheme world, or an idea from somewhere entirely separate. But one person promotes this idea, sends it to the editor in sort of canonical SRFI document form, and then the editor, which is me, publishes it, sets up a mailing list, and there's a discussion that goes on for ideally 60 to 90 days. That's the official rule, but sometimes 2 years, so on. So like I said, SRFI's been going on since 1998, and I took over as editor in 2015. So I'll go really quick here. This is just what the homepage looks like. There are 2 columns of SRFIs available. You can search and sort and see the abstracts and so on. But you can see right now we're on SRFI 235, starting at 0. There's another one just about to come out. I just haven't had time because of the workshop. But yeah, if you're interested, srfi.schemers.org is where it is. And it's got all the documents, including for withdrawn SRFIs, or for SRFIs that were proposed, and then people decided, we don't really like this, we can't really figure out what to do. I'll go over that later. There's sample implementations, and then email archives. So there's more discussion than you could ever want to have, and if there's not enough discussion going on right now, you can go back through the archives and find out everything that's ever said about a particular SRFI all the way back to 1998. There's a different mailing list for each of the SRFIs, and we have a bunch of other mailing lists as well. But I wanted to point out these here, the Scheme.org, just registry, test, and web. These are kind of outside of the SRFI standards process, just different topic areas that people are interested in discussing in the Scheme world. And so I've set up sort of little, since I have so many mailing lists already, adding these extra few was easy to do. And yeah, please join us. So I'm not going to go over all of these. I just want to give you a flavor. The SRFIs, I've categorized them by keywords. They're really labels, so each SRFI can have more than one, but there are a lot of different categories for what SRFIs can fall into. They cover all kinds of areas, from being compatible with SICP, like a library that makes it possible for people to run SICP programs in modern standard Scheme, to type checking, IO, et cetera, et cetera. And I mentioned before that I gave the talk in 2018 on the full history of SRFI. This gives more details about the history and so on. If you're interested, there's the QR code with the link to that talk from there. And there's also a video on YouTube, but I didn't give you a QR code for that because I don't want you watching that while I'm talking today. So an interesting fact here is that COVID, while it was terrible for the world and generally not a good thing, has been good for SRFI. I guess a lot of nerds sitting at home with extra time have managed to get a lot more done recently. We were already on a pretty good trajectory, but boy, since 2018 or since roughly 2019, we've gone for faster. It's not a large group of people who are contributing. Over time, it's a large group that has contributed over time. There are a few people who contribute a lot of new documents and proposals. And then there are a few who contribute one or two at a time. But we have a lot of discussion. We have a lot of people who are interested in the future of the language and in just kind of making it as good as possible. And I encourage you to join us too. Oh, I'm walking way too far from the microphone. Thank you. Okay, so I'm not going to go through all these, just to give you a flavor again of how much has been going on since ICFP 2018. Here is a full list of all of the ones that have in some way made progress since then. Some of them had already been started before the 2018 one, but yeah, we have a lot of, there are about 80 right here. Yeah, and Combinators is the last one, but there's another one coming after that. And then I should also mention that like with previous versions, with previous standards like R6RS, the SRFI process has been kind of used as part of the larger standardization effort. And in this case, for R7RS large, all of these SRFIs have been officially incorporated into what will be R7RS large, and more are coming. These last two are the ones that have happened since 2018, but yeah, there are quite a few. So there are way too many SRFIs, even just since 2018, to go through in detail right now. That's just too much. So I'm going to tell you a story instead. I thought of this idea while flying here. You know, I don't know if you guys have been on a plane where there's a seat back display that shows a map and the little picture of the airplane that's flying toward your destination, and you stare at it for hours and hours. So well, that's the example. Here we are coming toward Ljubljana Airport. Actually, Ljubljana is here and the airport's up there. That was an interesting fact I learned while making these slides. So let's imagine that we're trying to write a program like that displays a map and then shows a picture of an airplane flying in and gives you details about what airports you're flying over and stuff like that. What SRFIs could you make use of in the process? I just picked a random smattering of SRFIs and tried, fit them into this example, but I think it gives you an idea. So if you had an operating system interface which had a lot of optional arguments, so for example, if you're calling out to, I don't know, the ls subprocess, right? You can call ls to list your files with no arguments. You can call it with, an argument that says you want it sorted. You can give it a path that you want to list, etc. So maybe you want to wrap that operating system interface in some scheme code and have multiple, an arbitrary number of arguments for that as well. So SRFI 227 optional arguments gives you the opt lambda form and the let optional forms. These are not SRFI inventions. These are things that were actually widely used. They were used in a few schemes already, but people liked them enough that they said we really would like to see all schemes adopt these rather than just having one or two have them. So yeah, this is just straight out of the SRFI document, some examples of how let optionals and opt lambda are used. I'm not going to go into these in great detail. I just want to give you a flavor of what's out there. So this is a really strange one, which I actually really like. If you have hard-coded magic numbers, because you're reading a network protocol, right? You're downloading the maps from somewhere over the net, because planes actually have networks on them. I don't know if you guys know, it's kind of amazing, just like cars do these days. So you're downloading the maps from somewhere. You want to decode whatever that protocol is that's sending you the maps. Often there's some magic numbers that are encoded in hex that you want to read, and you want to encode them in your program. But those numbers are sometimes hard to read. So this is a very simple SRFI. It just says you can put underscores in your numbers and they'll be ignored, but the number will be read as usual. And it makes them easier to read. I like this particular one, feed dad food, is a lot easier to read than that long thing at the beginning. So those underscores, there was a long discussion about this. This is actually kind of typical of SRFIs in the sense that someone had an idea, suggested that maybe we can use underscores. I think it was Lassie Cortella. And then there was a long discussion where people realized that, yes, we need to not use commas and periods because some languages use one for the decimal point, and some, I shouldn't say decimal point, but for the divider between the fraction and the integer, and some use a different thing for between the fraction and the integer. We even learned that in certain Indian writing systems, the blocks are not by 3 every time or 4 every time. They alternate in size, right? So the nice thing about the underscores is you can just put them anywhere, and anywhere that makes it more readable to you, and the numbers work. So if you want to process the contents of binary files, I think R6RS has some of this, but homogeneous vectors of particular numeric types are very useful for that kind of stuff. So this just gives a flavor for all of the different types that are supported in this SRFI 160. And then SRFI 160 goes beyond what I'd seen before and sort of takes what SRFI 1 for lists did and makes just every kind of operations you can imagine for operating over homogeneous numeric vectors, for example, unfold right and drop while and all the usual things. So I'm just giving an example of 4 of them here, but if you look at that SRFI 160, it goes on and on and on and on with operators that make things easy. Okay, if you're using lots of curried procedures, that's pretty common when you're mapping over input from your airplane data. You might want to use a feature that was originally, as far as I know, in MIT Scheme. Hasn't made it out to a lot of other places, but is really very useful for that. So this curried higher order lambdas, you just add an extra level of parentheses around the identifier of the procedure, and that says that's how you do currying. So, for example, greet with prefix is a function that takes, is a procedure that takes a prefix string and returns a procedure that takes a suffix string that then string appends the prefix space in the suffix. Right? Very straightforward, but useful. You can see the sort of variation in SRFIs between the huge ones like the homogeneous vectors one and these tiny little one-offs. We have lots and lots of new data structures that have come in since last time, and I'll just give an example here. We have all kinds of hash tables and transducers and stuff like that, but for the specific case of a mapping between a set of numbers and a set of values, you can get a lot of optimizations that you won't get when you just use an ordinary hash table. So you can imagine using that if all your cities are numbered and you just want to keep a set of the cities that are visible on the map right now, mapping to the actual data on those cities. SRFI 224 creates these mappings and has an entire repertoire of procedures for operating on those mappings efficiently. For image processing, SRFI 231 is not quite finalized, but I decided to include it already because actually Bradley Lucier, a mathematician who's been working on this, this is actually his 3rd SRFI in the same area because he keeps coming up with even better ways, extensions on the original array processing SRFI that he did many years ago. I think 179 was the previous one, 231 is compatible with it, but adds more and more and more capability. But here's an example of doing some image processing, array copy, array map, array fold L, all those operations are operations on arrays. It supports sparse arrays, it supports fully fleshed out arrays, every kind of operations you can imagine. And a lot of ideas were actually taken from, I forget the name of the package, but there's a Python package, which is now kind of the way that people talk about doing arrays, especially in the machine learning world. I think PyTorch might be what it was. What's that? Okay, thanks. Anyway, so the scheme world is incorporating ideas, as always, from other places, and this is an example. And then say you wanted to generate some API documentation. There's a nice SRFI 166 monadic formatting that just lets you do textual formatting in very easy ways. So in this example, we just define func to be an S expression that represents the source code for some function that you want to display. And doc is a string that is the documentation of that function. And here, this is out from Alex Shin's Chibi scheme. This is another example of taking an idea from one implementation and trying to spread it around. This says, I want you to show the output of of columns. The first one is an infinite column of line numbers, flush right, 4 characters wide. The next column is take that variable function and pretty print it on however many lines you need. The next is just put semicolons in. And the next is the text string justified. So this SRFI has just all kinds of operations for manipulating text in this kind of way. This is just a very, very quick taste of what it's like. I would love to see something like this actually for not just for pure textual output, but this is a good start. And by the way, Alex made sure that it supports full Unicode and understands things like character widths and so on. Reading and writing JSON. So for example, in this example, we might want to read our map data from JSON files, or maybe just configuration files. So we have fairly advanced SRFI for reading and writing JSON. And it even handles the case where the JSON is too big to fit into memory at once, so you might want to stream it. So it's kind of a standard streaming API. And then here's another small example. You have a library procedure that returns vectors, but you want to pass it to something that returns that expects multiple values. So you can write that. That's easy to write. But vector values here knows how to take a vector and turn it into multiple values. And this SRFI is just full of examples like that for different data types, converting them to and from, splicing multiple values, and et cetera, et cetera. We're getting close to the end here. We're factoring a long series of operations from left to right. So, I'm pretty happy with, the kind of right to left, outside in way that S expressions tend to make you operate. But sometimes, if you're doing a multi-pass compiler, for example, you really sometimes want to just show things left to right. So we had an author who suggested this chain macro that lets you essentially say, I want you to compute a value and then pass it into the next expression and substitute it where the underscore is. And then the result of that expression being evaluated gets passed into the next expression and substituted where the underscore is, et cetera. It's actually fairly easy to read and understandable. We have some earlier SRFIs that do similar things with slightly different syntax, but this seems to have hit a really sweet spot for this idea. So that was just 10 SRFIs. There are 236 now, 80 since 2018, more are coming. But I figure that gives you a flavor of how things have been moving. We're not yet where Go and Python are. Right, they have just vast collections of libraries, and that's actually one of the main reasons that people like those languages. But we're getting there. We're getting more. And actually, SRFI isn't the only way that the language is being extended. So Accu.com and Snow are both great places to look if you want to see things that, packages that have been made for Scheme. SRFIs are widely used. The community is really pleasant. We have lots of discussions. People don't always agree on things, but it's always polite. We keep it very civil. So I'm encouraging everyone here to, peruse the SRFIs, use them in your own work, and help implement them for your languages. Racket might pick up some ideas from us too. Yeah, that's right. And please help make more. And helping to make more, it doesn't just involve you proposing a SRFI, an idea that you have. That's of course welcome, but it can also just be participating in the discussion. It really, we've had SRFIs that started off kind of raw, and by the end are really nicely polished things that lots of people agree are really worth using. And one particular thing I'd like to ask for is there are a few SRFIs that need reviving. There's one in particular, SRFI 204, which is on the right card-right shin pattern matcher, which is a really nice system that a bunch of Scheme implementations use. It isn't really specified really precisely yet. Someone made an attempt, and it went on for about 2 years, and we finally had to withdraw it because progress wasn't really being made. But it'd be really great to go back to this withdrawn SRFI, initiate a new one, and get it, pull it all the way through to finalization. So yeah, thanks very much for listening, and please contribute and use them.